Alright, in today's video I'm going to show over 8 properties of light. I know I'm late, but whatever, let's just start. So, first property we have, light goes in a straight line. You can't be more straight than light. I mean, light is very, very straight. If light touches an object, it's not gonna bend over around the corners of the object. That's not going to happen. What's going to happen is either light is going to be absorbed by the object or it's just going to be reflected elsewhere. And that's just it. Also to note, the speed of light is 300 kilometer per second. So that's the speed of light. And also, light's trajectory can be deviated. That's called refraction, but I'll just look into refraction later on in the video. For now, let's just move on to the second property. So, second property is light comes from two different sources, either natural source or an artificial source. So an example of natural source, we have the sun, right? And an example of artificial source, we have a light bulb. Yeah, this is just self-explanatory. Natural, it comes from nature. Artificial, it comes from humans. I'm sure you guys understand. Pretty easy so far. So that's the second property. Let's move on to the third. So third property, light carries, carries energy. So light carries what's called light energy. And light energy, the definition is a kind of kinetic energy with the ability to make types of light visible to human eyes. You don't need to learn this, just know light carries light energy. And when light touches an object, it converts into thermal energy. And the symbol of thermal energy is Q. And the unity they use is J, that stands for joule. So yeah, so light converts into thermal energy when it touches an object. This is why when you go outside, when it's sunny outside, it's hot. Also, light can be converted into different types of energy. For example, we have photosynthesis. This time, light would be converted into chemical energy. So in photosynthesis, light energy gets converted into chemical energy. And in the case of solar panels, light energy gets converted into electrical energy. So yeah, there's that. That's property number 3. Light carries light energy. Now let's move on to the fourth property. Light is a electromagnetic ray. It's a pretty long word, but it's not too complicated. So electromagnetic, I'm sure you're familiar with electromagnetic spectrum. So it's this, right? So we have waves, and then frequency goes higher like this. So I'm sure you're familiar with radio rays, microwaves. We have infrared, we have light. So on the left, we have radio waves, and then we have microwaves, and then we have infrared, and then in the middle, we have light. Visible light, I should say. So we have light, and then it goes UV for ultraviolet waves. And then it's X-ray, and then it's gamma rays. Both X-rays and gamma rays are radioactive, so be careful for that. So in this section, right, this section is visible light. And in visible light, when we zoom in the section of visible light, we can see the 7 colors of the rainbow. So we have red, we have orange, we have yellow, and then it's green, then blue, indigo, and then finally purple. So the 7 colors of the rainbow. And also, light is the only electromagnetic ray that humans can see, right? I'll just draw an eye here. So the only ray that's visible to human eyes. And radio, micro, infrared, UV, we can't see them, right? And also wavelength. Okay, so I'm just going to explain. So to the left, the wavelength is bigger, and there's less energy here to the left, and there's also it's colder, right? When there's less energy, it's colder, right? Makes sense. And then to the right, the radioactive rays, gamma, there's higher energy and it's hotter. And I should say the frequency is higher, so higher Hz. So to the right, it's higher energy, it's hotter as well, and the frequency is higher. And then to the left, the frequency is lower, right? Lower frequency. So yeah, I guess that's property number 4. Light is a electromagnetic ray. I'd say this is the most complicated one, but I'm sure you just study and then I'm sure you'll understand. So yeah, this is the 4th property. I hope this is clear to you guys. So yeah, we'll just move on to the 5th property. So 5th property, we have reflection. So reflection, I'm sure you guys know, it's when light touches an object and then gets reflected. And yeah, that's just the basics of reflection. There's 2 types of reflection. There's this one to the left with a smooth object, and then to the right we have water. So in this one, light enters the object and then gets reflected. In this case, because the surface of this is smooth, there's only one direction that light gets reflected. This is called specular reflection. So light gets reflected in a single direction. And in the case of water, light gets reflected pretty much anywhere, right? It just gets reflected anywhere because it's not smooth, right? It's water, right? So it just goes anywhere. And this is called diffuse reflection. So yeah, specular goes in a single direction, diffuse goes into multiple directions. Also, this is not all. I have also to specify the colors it also depends on the color of the object. So to the left we have a white object, and to the right we have a black object. So what happens when light touches a white object? There's a little amount of light gets absorbed, and then the rest of the light rays gets reflected, right? Light, white surfaces reflect light, right? Usually white objects, they reflect. However, in black objects, when light touches black objects, they get absorbed more. And then there's going to be a small amount of light that gets reflected. So, yeah, in black objects, light gets absorbed. In white objects, light gets reflected. This is not all. I also have to explain colors. So colors, right? Let's say we have a red ball, and it's red. Okay, we have a red ball, and light. Oh, that's not red. Wait, what? Okay. Okay, finally. Okay, so light touches a red ball. Didn't I say in the previous slide or property, visible light is the 7 colors of the rainbow, which is like every color that we know of, right? So light, I'd say it's white light, right? Because white is every color. Because white reflects like white, it just reflects light, right? So light is every color and touches the red ball, so it will absorb every color except red, and the red rays will just go into our eyes, and then this is why we see the object as red, because there's red rays that enters our eyes. And yeah, same thing will be applied if it's a green ball. So if it's a green ball, it's going to absorb every color except green. It's going to reflect green rays. If it's a blue ball, it's going to reflect blue rays, and it's going to absorb every colors. And yeah, okay, I hope this is clear enough to you guys. I think this is it for Reflexion. I think there's, oh wait, I think there's, oh, no, that's not. I think there's one last thing with Reflection. So I'm just going to name the parts of a reflection. So we have the light that comes, and then we have the light that gets reflected. In the middle, there's always like some middle part that just splits the two rays, right? And this is called the normal, I think. I know in French it's normal. I think it's the normal. I'm not sure. You'll have to look it up. So there's a middle line between the two rays, and this ray that just comes, the ray that comes is called the incident ray. Light, incident light. And the light that gets reflected is called reflected light. And also to note, it forms with the normal, it forms two angles, right? This angle, the incident angle, its symbol is going to be theta I. This is going to be the angle for this angle right there, and then the angle from the other side, its symbol is going to be theta R for reflected. So yeah, these two angles, they're the same because it's a it's a smooth object, it's a specular specular reflection. So of course the two angles are going to be the same. So yeah, I think this is it for reflection. Yeah, I think this is it. We'll just go over to the sixth property. Sixth property is refraction. And refraction is when light enters different environments. For example, let's say we have air, and then below is water. So what will happen is light will enter the water, then there's going to be some light that gets reflected, and for the light that gets absorbed, it's going to be going under water. And as you can see, the trajectory of light will be deviated, right? And it just looks a little weird. This is why when you put a pencil in a glass of water, it's going to break down. Well, it's not going to break down. It's just going to look like it's breaking down. So why this happens is, didn't I say that speed of light is 300 kilometer per second, right? That's the speed of light in air. In water, it's much, much slower. There's a formula to calculate the speed of light in certain environments. So, and this formula is N equals C divided by V. N is hint of refraction, C is speed of light, and V is the new speed. So the hint of refraction, you're going to use this formula if you want to know the new speed of light in a new environment. For example, the hint of refraction for water is 1.33. You're going to use this to convert the speed of light, and the speed of light is 300 kilometer per second. And what we're going to look after is the V symbol. And how you get the V, you just do V equals C divided by N. And yeah, you just do this. That's just it. And if we're going to calculate, we're just going to V equals 300 kilometer per second divided by 1.33, and then we're just going to calculate. I think it's going to give 225 kilometer per second. It's going to give an answer like this. If you look in your science manual, there's going to be a bunch of hint of refractions. You're going to see hint of refraction for glass, for diamonds, and for whatever. So yeah, this is how refraction works, right? I guess this is pretty easy so far. Hope this is easy for you guys. So we're going to move over to the seventh property. Seventh property is dispersion. And dispersion is when light gets split, it splits into all colors, the 7 colors of rainbow. So light goes this way, and then it'll hit a prism. It's going to do a refraction inside the prism, and it's going to do another refraction when it's going to go out, because it goes from glass to air. And it's going to, when light enters a transparent environment such as glass, it just goes out. It's just going to go out with every color of the rainbow. So we have red, orange, yellow, green, blue, indigo, and then purple. It's going to look like this, right? And this is how you explain rainbows, right? So how rainbows work? It's light, okay, the light from the sun. When rain stops, there's going to be raindrops in suspension in the air, and these raindrops are just going to be in suspension, and light is just going to enter raindrops, and then it's just going to do a refraction inside the raindrops, and then it's going to go out with every color of the rainbow. So this is how rainbows work, and yeah, this is it for dispersion. I mean, pretty easy. So just light gets when light gets split, it splits into all colors. And finally, last but not least, we have shadows. Shadows, I mean, you guys know what shadows are, right? Shadows are shadows. They're formed because light goes in a straight line, and well, light can't bend over around objects, right? So it has to form a shadow. And I'm just going to illustrate this. So we have a flashlight here to the left, and we have a ball here, and to the right we have a wall. So when the flashlight is turned on, the ray, we're just going to pick the ray to the top of the flashlight. It's going to the top of the ball, and then it's going to hit the wall. We're going to do the same thing for the bottom of the flashlight. We pick the bottom of the flashlight, bottom of the ball, then it's going to continue like this, and it's going to form a shadow here. And this shadow is going to be black, like just black. And yeah, this is how shadows work. There's another form of shadow, it's called penumbra. So penumbra is like the small region, it's like a small region around the shadow with slight light in it. And how penumbra works is you take the top of the flashlight, it goes, instead of going to the top, it goes to the bottom, and then it's going to hit the wall. We're going to do the same, bottom of flashlight, go to the top, and then it's going to land on the wall. And it's going to form a small region around the shadow, and this is penumbra. And yeah, this is how shadows work. I mean, I think this is it for shadows. And yeah, I guess we described light. I mean, those were the 8 properties. Thank you for listening. And yeah, I hope you guys understood. And yeah, we're just going to see each other later. Toodles.